So we're still solving systems of equations, but this time our equations will have 3 variables. Whenever you have 3 variables, you're actually talking about a plane instead of a line. So sometimes it's hard for people to see 3-dimensional drawings like these 2 examples right here. In this first example, you have a red plane, a blue plane, and then a green plane. And sometimes that's kind of hard to get a grasp on. And in both of these, we have those 3 different colored planes. You can notice in the first one that all of these 3 planes actually intersect in one single point right there, right? Well, look at the second example. In the second example, all of the planes intersect in a line. So you can see that we could have different outcomes depending on how our planes intersect. So just to give you a real life example of that, I took some pictures of my ceiling and my walls. So you can see this is a ceiling. By the way, this is a flat ceiling. It looks like it's angled, but it's actually flat. This is a wall, and this is a wall. So imagine if these 3 planes continued past what you could see. Alright, so all 3 planes actually intersect in that one point right there. Well, what if for some reason we were only interested in this plane, which is the horizontal one, and this plane, which is a vertical one? What if we only had those 2 planes? Those 2 planes actually intersect in a line, right? I actually have another example. This ceiling is slanted. It actually goes up really steep on this side. So you can see this plane would go at an angle, but these 2 are vertical. But they also intersect in a single point. So it depends on how our planes intersect as to what our solution is going to be. So this gives us a singular solution. This one gives us infinitely many solutions in the form of a line. But look at these. Do these 3 planes intersect in one place? The green intersects the red and blue, the blue intersects the green and red, and the red intersects the blue and the green. However, all 3 of them don't intersect anywhere. This would give us no solution. Same way with this one. We have 2 parallel planes and one that cuts them. The red one does intersect each of the others, but they all 3 don't intersect somewhere. So this one also has no solution. So look at this one. We have 3 parallel planes. You can think of this as like the first floor, the second floor, and the third floor. And we're actually talking about the floors themselves, right? Do those floors ever intersect? Well, we hope they never intersect. Otherwise, when we have a hurricane, not a hurricane, an earthquake or something like that. So in this case, we also have no solution. So this is one solution, infinitely many solutions, and all of these represent no solution. So I do want to say that when you're solving these types of problems, just be very neat, be very organized, and be very methodical.